to our discussion. I'm Aicynth Lee Bandiola, and today we're going to talk about gas law. So, what is gas law, you might ask? Well, gas law was created in the early 17th century, and it was there to assist scientists in finding volumes, temperature, and pressure when it comes to matter of gases. Now, gas law consists of three primary laws, which are the Boyle's law, Charles' law, and Avogadro's law. But in this discussion, we will be tackling five gas laws, which are the Boyle's law, Charles' law, Avogadro's law, ideal gas law, and Guy-Lussac's law. But what really is gas law? Well, just a general idea, all gases behave similarly when the conditions are normal, and gases behave based on the motion and the relative distance between particles and gases. Now, when there's a slight change in their physical conditions, such as their temperature, pressure, and volume, can have a little bit of deviation when it comes to the results that we're looking for. Now, gas laws are the analysis of the behavior of gases. The variables of state like pressure, temperature, and volume depicts its true nature. Hence, gas laws are relations between these variables. The three fundamental gas laws that I've stated, which are the Boyle's law, Charles' law, and Avogadro's law, have found a relationship between the volume, temperature, and pressure, and number of moles. So, before we dig into our lesson proper, we will have first an overview of what we're going to talk about. Now, let's start first with the Boyle's law. Well, Boyle's law states that volumes of gas increases as the pressure decreases, so it is inversely proportional. Volume and pressure is inversely proportional. Charles' law states that the volume of gas increases as the temperature increases, meaning the volume and the temperature is directly proportional. Avogadro's law states that the volume of gas increases as the amount of gas increases, so it means that the volume and the amount of gas is directly proportional. Ideal gas law is the combination of the four gas laws, and last but not the least, Guy-Lussac's law states that pressure of gas increases as the temperature increases, so it is directly proportional. So when you look at the five gas laws, well, not including ideal gases, so it's just four. Only Boyle's law is different because its variables are inversely proportional. So before we really dig into our lesson proper, we'll have first a recap, or let's just refresh our minds of the terminologies that we will be using in this lesson. So first, we have the temperature. So temperature, it is a property of matter which reflects the quantity of energy of motion of the component particles. So it is basically how hot or cold an object, or like solid, liquid, or gas, how hot or cold it is. So the units we use are Kelvin, Celsius, and Fahrenheit. But in this discussion, we will most likely focus on Kelvin. Next is the volume. Well, volume, it is the quantity of three-dimensional space occupied by a solid, liquid, or gas. So how much water is inside the container? And the answer to that is the volume. So the unit we use is liters, milliliters, ounce, gallons, and cubic meter. And last but not the least is pressure. It is the measure of force applied over a unit area. The units we use for pressure are pascals, Newton per square meter, the atmosphere, torr, bar, milliliters of mercury or mmHg, and meters seawater. So let's go now to our first lesson, which is Boyle's law. Boyle's law was discovered by the Anglo-Irish chemist Robert Boyle in the year 1662. Boyle's law is a gas law which states that the pressure exerted by a gas kept at a constant temperature and number of moles is inversely proportional to the volume occupied by it. In other words, the pressure and volume of gas are inversely proportional to each other as long as the temperature and the mass, or the number of moles, is kept at constant. As per Boyle's law, any change in the volume occupied by a gas at quantity and temperature will result in a change in the pressure exerted by it. In other words, the product of the initial pressure and the initial volume of a gas is equal to the product of its final pressure and final volume at a constant temperature and number of moles. So as you can see here in the picture, we have a container filled with water. The first photo or the first container has more volume and lesser pressure because the particles can move freely compared to the other one. On the right side, the container has lesser volume. It means that there is more pressure, means the particles cannot move freely compared to the first example. Now, this law can be expressed mathematically as P1 V1 is equals to P2 V2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume occupied by a gas. So let's take note that when it comes to Boyle's law, pressure and volume is inversely proportional to each other. So when the pressure goes up, the volume goes down. The volume goes up, the pressure goes down. Okay, so moving on to our next lesson, which is Charles' law. So Charles' law was created in the 1780 by French physicist Jacques Charles. Charles' law states that the volume of an ideal gas is directly proportional to the absolute temperature at a constant pressure. So the variables we are talking in Charles' law is the volume and the temperature. And again, it is directly proportional. So when the volume goes up, the temperature goes up. The law also states that the Kelvin temperature and the volume will be direct proportion when the pressure exerted on a sample of a dry gas is held constant. Charles' law, also sometimes referred as the law of volumes, gives a detailed account of how gas expands when the temperature is increased. Conversely, when there is decrease in temperature, it will lead to a decrease in volume. So just for an example, if you notice, well, not here in the Philippines, but when you see a tire in the cold snow, the tire is more likely to be deflated or like have lesser volume of air. Now, so Charles' law can be stated in a mathematical equation, which is V1 over T1 is equals to V2 over T2. So V1 is the initial volume, T1 is the initial temperature, V2 is the final volume, and T2 is the final temperature. So let's take note that in Charles' law, it is V and T. So the variables we're going to use is volume and temperature, and they are directly proportional. So moving on to our next lesson, which is the Avogadro's law. So Avogadro's law was named after the Italian scientist Amedeo Carlo Avogadro, who suggested that the two dissimilar ideal gases occupying the same volume at a constant temperature and pressure must contain an equal number of moles. So in here, in Avogadro's law, the variables that we will be talking about is the number of moles and the volume. So again, it is directly proportional. So when the volume goes up, the number of moles goes up. When the volume goes down, the number of moles goes down. So Avogadro's law, also known as the Avogadro's principle or Avogadro hypothesis, is a gas law which states that the total number of atoms or molecules of gas is directly proportional to the volume occupied by the gas at a constant temperature and pressure. Avogadro's law is closely related to the ideal gas law equation since it links temperature, pressure, volume, and amount of substance for a given gas. As you can see here in the graph, you can see that in Avogadro's law, when the volume goes out, the moles goes up, the number of moles goes up, and the constant here are pressure and temperature. Now, the Avogadro's law can be explained mathematically, which is the V1 over N1 is equals to V2 over N2, where V1 is the initial volume and 1 is the initial number of moles, V2 is the final volume, and N2 is the final number of moles. So moving on, our next lesson is Gay-Lussac's law. So Gay-Lussac's law was formulated by French chemist Joseph Gay-Lussac in the year 1808. So Gay-Lussac's law is a gas law which states that the pressure exerted by a gas at a constant mass and volume is directly proportional with the absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of gas when the mass is fixed and the volume is constant. So we can assume in Gay-Lussac's law, it is the pressure and temperature. So the variables that we are talking about is the pressure and temperature. So it is, again, directly proportional. So when the pressure goes up, the temperature goes up. So this graph shows how the Avogadro's law works. So when the pressure goes up, the temperature goes up. So Gay-Lussac's law can be explained mathematically, which is P1 over T1 is equals to P2 over T2, where P1 is the initial pressure, T1 is the initial volume, P2 is the final pressure, and T2 is the final temperature. So before we move on to our last lesson, let's have first a recap of our lessons. So first we have the Boyle's law. In Boyle's law, we only talk about the variables, the pressure, and the volume. And it is inversely proportional, so when the pressure goes up, the volume goes down. Next one is the Charles law. In Charles law, the variables that we are tackling here is the volume and the temperature, and it is directly proportional. When the volume goes up, the temperature goes up also, and when the volume goes down, the temperature goes down. Next is the Avogadro's law. In Avogadro's law, the variables that we are talking about is the volume and the number of moles, and it is directly proportional. When the volume goes up, the number of moles goes up also, and when the volume goes down, the number of moles goes down. And the most recent lesson we had is the Guy-Lussac's law, and the variables that we are talking in Guy-Lussac's law is the pressure and the temperature. So when the pressure goes up, the temperature goes up, and the pressure goes down, the temperature goes down. It is directly proportional. So for final discussion, our final lesson, we will be talking about the ideal gas law. So ideal gas law was stated by Benoit Paul Emile Clapeyron in 1834. It is a combination of empirical Charles law, Boyle's law, Avogadro's law, and Guy-Lussac's law. It is the product of the pressure and the volume of 1 gram molecule of an ideal gas is equal to the product of the absolute temperature of the gas and universal gas constant. Ideal gas law can be stated in a mathematical equation, which is the PV is equals to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the ideal gas constant, and T is the temperature. So I think that sums up our lesson. So before we finally end this discussion, let's have first a sample problem. So get your papers and answer it with me. So the first example is a sample of gas with a volume of 1.45 liters exerts a pressure of 780 torr. What is its volume if the pressure becomes 740 torr at a constant temperature and amount of gas? So the only variables here that we are concerned of is the volume and the pressure. So if we have a recap of our lesson, only Boyle's law tackles with volume and pressure, where the mass and the temperature is kept at constant. Let's find the given first. So first we have the 1.45 liters, so that is the initial volume, and then the initial pressure, which is 780 torr. The next is the final pressure, which is 740 torr, and what we're looking for here is the volume. So what we're going to do is we get the mathematical equation of Boyle's law, so it is P1 V1 is equals to P2 V2. So the initial pressure is 780 times 1.45. So to be able to get the final volume, we have to transpose the pressure. So we put the pressure on the denominator of the P1 V1. So it is 1.45 liters times 780 torr over 740 torr. So the final volume of a sample of gas is 1.53 liters. Now, another example, a sample of gas with a volume of 6 liters is heated from 35 degrees Celsius to 75 degrees Celsius. Calculate the new volume of gas if the pressure remains the same. If you look at the question, the only variables that changes here is the volume and the temperature. If we look at our lessons, only Charles law talks about the volume and temperature, where the moles and the pressure is kept at constant. So let's first list down the given. We have the initial volume, which is 6 liters, the initial temperature, which is 35 degrees Celsius, and the final temperature, which is 75 degrees Celsius. What we're looking for here is the final volume. So before we start with solving, let's first transform our Celsius to Kelvin. So in order for us to transform Celsius to Kelvin, we add the Celsius and the 273 Kelvin to make it Kelvin. So for the initial temperature, it is 35 degrees Celsius plus 273 Kelvin, which makes it 308 Kelvin, and 75 degrees Celsius plus 273 Kelvin, which makes it 348 Kelvin. So let's look at the equation, which is V1 over T1 is equals to V2 over T2. So V1 over T1, what we're looking for here is volume, so we transpose T2 to our V1. So it's this V1 times T2 over T1. So our V1 is 6 liters, our T2 is 348 over 308 Kelvin. So that sums up to 6.78 liters. I hope you have learned something or just a little bit from our discussion, and thank you for listening. Bye!